I welcome you all to our Certified DevOps Engineer Life Free Training Program. This is our roadmap, and according to it, we have completed very successfully day 1 to day 6. And today we are going to start day 7, Container Orchestrator. And the one and only ultimate tool is the Kubernetes, is the focus of the day. So, as usual, this is our training registration page, right? But this time I want to announce something different apart from all this training. So we are going to soon announce for certified Kubernetes application developers training program. So of course you guys are already registered. I will notify you as well, and those who wants to join later, they can enroll this for this certification, and that training will also free and live. So feel free to do that if you want to. And of course, thank you very much for your kind support and love which we are receiving. These are our social media links. Feel free to connect. So what we will cover today. So today, this session, or I would say day 7, is divided into 3 sections. First section is our Kubernetes essential. In this, we will see all the Kubernetes components, its architecture, what node, what control plane, what is Kubernetes, all the basic stuff we will do in this. We will see in this section, and then we will, after that, we will go in deep dive section, right? And in this, we will be seeing all the important objects of the Kubernetes. So these are not component, these are objects we can create inside the Kubernetes cluster. We will also see the how Kubernetes YAML structure, or how we will write our own Kubernetes YAML files. Okay, then we will end with the, or we will wrap up our session with the real world project, and in that we will deploy one of the application using all these technologies. So then this will give you idea how actually Kubernetes work when we have multiple different technology, multiple different application inside, right? So of course this is database, this is in-memory database, .NET is there, Python and Node, and so that we will do. So we have to cover a lot, so let's directly go into it. So first thing, Kubernetes essential. In this, first we will start with Kubernetes essential. So let's first thing first, what Kubernetes is. So Kubernetes is the ultimate open source platform for orchestrating containerized application, right? We already saw in our day 6 what containers are there, okay, how we can create a container. And when we have so many containers, so we need something to manage the containers, right? And not only just for the management of the container, we will see there are awesome things which is provided by the Kubernetes. So we will see that, and you will realize why Kubernetes is one of the, or I would say, yeah, the ultimate tool for orchestration, right? And it was originally developed by Google and is now maintained by the Cloud Native Foundation, that is CNCF. In Kubernetes certification, we will see more in this CNCF part, right? What this is. And Kubernetes ensures also, apart from that, Kubernetes ensures your applications run smoothly across the multiple environment, whether you are running your application on premises or in the cloud or bare metal or VM, anywhere. So Kubernetes is one of the platform or one of the tool which you can configure anywhere. Okay, that's a really amazing tool. And whether you are running one container, 3 container, or 300,000 containers, Kubernetes got a cover for you. Okay, so that's how Kubernetes is really powerful. We will see ultimately we really do not run the containers, right? So but Kubernetes supports up to 300,000 containers. So we will see that later, okay, when we go actually to our terminal, right? There are some fun facts about the Kubernetes, and first one is the name Kubernetes originates from the Greek meaning helpsman, or simply the pilot. And there are this K8 as an abbreviation in between. There are 8 letters in between K and S, and that's how it becomes K8s, right? So it's very common practice. People also use gets instead of Kubernetes, but it's completely depends on you, So if somebody says skates, it means understand they are referring about this thing. So that's how it becomes like this. And Google open sourced the Kubernetes project in 2014, and before making it, so I mean Kubernetes derived from other projects as well. If you want to read about this, this is the link, right? Reference link. Go over here. You will find about the Bob, one of the project, right? And I think Omega is also one of the projects. So Google was running this in-house tools more than 15 years, and based on that, they derived the Kubernetes, and that's why Kubernetes was got very attention in the community. Many people joined, and now it's more than 10 years, the Kubernetes. So it's very much mature. I started with 1.6 version, so I have been witnessing what is happened since then, and now I think 1.35 version is there, right? So let's do and go ahead and see what we have next. So these things, I mean, there are more fun facts, right? You can go on this link and read about that, but these are the some of the things I thought to share with you. That's why I shared. So this is about what Kubernetes is. Next topic is our Kubernetes architecture and component. So here now we know the what Kubernetes is, but this is one of the, or I would say, yeah, another important thing. So meanwhile, before we go ahead, do you have any questions on this, on the Kubernetes? I explained what Kubernetes means is. No, okay, thank you so much. So I went, okay, Anish, thank you. So I went a bit faster, but there was nothing, it's just a theory, but some other fun facts because we have to cover a lot of things, okay? But if you have something, just raise your hand, and or maybe if you want chat in a post, I mean post in a chat, I will also answer later. So first thing in Kubernetes architecture, right? So in Kubernetes architecture, here there are two things. I mean, I don't know, I'm not, let's put it in this way. Okay, so people, you maybe heard about from the people, the Kubernetes is very complex technology. So as per my understanding, so people, whether they don't understand or they do not have proper understanding about the Kubernetes, that's why they say, okay. So that's why I will emphasize on this point a little bit more. Okay, so let's go ahead and see first thing. So Kubernetes architecture and component. So first component, okay, first we will see the components, then we will talk about the architecture. So first component is the API server. So API server is the cluster's front end door. Okay, whatever any request comes to, or any request come to that cluster, which has to go through the API server. Okay, so API server is the front end of the cluster. What and how we interact with the API server? So very simple thing. When we run commands like this, kubectl get pods, okay, so just hold on the commands. Okay, we are coming on that, and we will discuss in very detail. So just here I'm giving you the idea how we interact with the API server. So when we execute this kind of commands, right, so it goes to the it means we are communicating with the API server, and API server interact with the rest of the components within the cluster or within its own side and give us these details. Okay, so always we send request to this, and this replies to back. So this is one thing. When you want to check, let's say deployment, pod, or anything, service, whatever, okay, always you are communicating with the kubectl, I mean not kubectl, Kube API server. This is one of the way. There are more ways as well. You could interact with the GUI version, you could interact with the directly API, right? You could and this is the way of the CLI, which is most of the time you are going to interact with the Kubernetes cluster. Okay, but yes, there are more ways as well, but as a DevOps engineer, I believe most of the time we go ahead and do with the use the kubectl, right? So next we have second component, that is etcd. So etcd is a distributed reliable key value database. Okay, so we know database, it means we want to store some data, right, into the database. That's why we need a database. In Kubernetes we have a etcd, and which is key value based database. So it stores the desired state of the cluster. Okay, so please make a note of this word desire, because we are going to talk about this several times throughout this session. Okay, so desire, it means whatever we want. So yes, whatever we want here is the, yeah, literally whatever we want with the cluster, that is the desired state. Okay, so that state is stored in etcd. Okay, so this is the database which stores the state. So we will see what desired state it means, but what kind of object, for example pod, right? Pod specification, number of pods you want, what kind of deployments you need, or sorry, number of replicas you want, secrets, everything is stored here. If there is no etcd, there is no cluster at all. So this is another, I mean, of course all components are important, but this is the thing, or this is the component of the cluster where you probably, or not probably, you have to take backup, and the thing which you want to preserve. Okay, so etcd is the thing, right? Okay, so this is etcd database. And how you interact, you typically interact with the etcd directly for the debugging or backing up purpose, nothing else. So when you run on your node this command etcd, exactly the same. Okay, etc etcd-ctl, like kubectl, similarly etcd-ctl underscore api 3, and this get keys only. So we want to see only keys, so it gives us sample pods, sample deployments, sample services, right? So keys for the cluster objects, right? We, by this command we want to see. So that's how we get the information. Okay, so this is about the storage. This is the database which stores the desired state for our application, right? Or for the cluster what we want. This is the database. Next component we have Kube-Scheduler. So Kube-Scheduler responsible for assigning pods to worker nodes. Okay, so we will see what worker nodes it means. So but for, or you could say, okay, worker node simply those who actually handles the workload. Okay, so scheduler is the one of the responsible component in Kubernetes cluster. When you create any pod, or even you deploy anything, right? Or when you do the deployment, not anything, then this Kube-Scheduler, based on the factors like CPUs, memory, affinities, rule 10, tolerance, there are advanced topics as well, but just for simple understanding, you could say based on the CPU and memory, it decides, okay, where should I schedule this pod. Okay, so this is it's a job. We will see in action where it comes. Okay, so this is the scheduler. Then we have like, if you want to see how it works, so when we run this command kubectl get events, that will also give you the output. But this is the additional flags followed by, you can use it with many with the deployment, with the pods, or with the services, or whatever. Okay, so additional flags, it says dot metadata dot creation timestamp. Okay, and it gives you like this. Okay, successfully assign my pod to worker node 1. It says, okay, nodes are available, and it says warning and failed scheduling because insufficient CPU. So this kind of events you can, I mean, these are the tasks of the scheduler, and we can see in the event. Okay, then next we have the Kube-Controller-Manager. Okay, so Kube-Controller-Manager runs control loops or the controller. So basically what it does, it monitors the cluster state. Okay, so cluster state, it means when we created deployment, right? In deployment we mentioned, okay, we want to have a number of replicas 10 or 20 or 100. So we initially says, okay, this is my desired thing. Okay, and which is stored in etcd. So it continuously watches what is desired and what is current. Okay, so this is the work of the controller. I just give you one example. There are several other kind of controller as well. So we also have controller for namespace, replica sets, and other as well. But here it's a basic job. It's to monitor the cluster state and take corrective actions to ensure it matches the desired state. Okay, so this is the job of the controller. So for example, here when we say kubectl get replicas, and I just execute this command, so here you could say desired number, current, ready, and all these things. Okay, when I scale it up, right, so it is scaled from 2 to 3, and now if you see the desired, current, and ready are different. If you want to check a log, execute this command, you will get more information about it. Okay, so this is just a high level overview. This will automatically, you will get, or all the dots will be connected when we switch to the terminal. But I believe this is important to give you at least a high level overview. Okay, so this is our the controller manager, and as I said, we could have a for managing a node, we have a node controller, right? Namespace controller, replication controller. So there are so many controllers, and I will also tell you where you can see this. Okay, so this is about the controller. Next we have kubeblade. So kubeblade is a next component which is critical component in Kubernetes. Why it is critical component? So it's kind of agent that runs on each node in the cluster. Okay, and so as name suggested, it's an agent, right? So agent, it means it has to report somewhere. That's why it's an agent, right? So it ensures that containers are running properly, and it communicates with the Kubernetes API server, okay, to get the instruction. So kubeblade directly communicate with the API server. So whatever API server instruct, it perform the same. Okay, and there are so many, I mean, there are other components as well, but kubeblade is the one of the important on the node which directly communicate with the API server. Okay, so if I want to see kubectl get ports, all namespace field selector. Again, so dash dash field selector, I set space dot node dot name and node name one. So this shows all the ports running on this node name dash one. I just give a name, so you can give any name over here, whatever name of the your node. We will see how we can check the name of the node when we setting up our on cluster in a shortly. So on this, for example, this node name one is this one. So all the ports which we are running, it will list everything over here. Okay, and but here the selector is this one in all namespaces. Fine. So this is the kubeblade. Yeah, how you can see the kubeblade logs. So when you go ahead and see, we talk about in our Linux day one, right? How we can see the logs of the particular user. So sudo journalctl -u, it means it's a user, right? And this user is kubeblade, right? And if you see over here, I put some of the logs when you do follow along later, or you are doing, I don't know what, when. So when you execute this command, so some of the important thing I have mentioned over here, it says started kubeblade, the Kubernetes node agent, right? So it's an agent, this is the version, right? It also says CRI implementation should be updated and supported runtime. So we'll see, this is also our the next component in the Kubernetes. Okay, container runtime interface. Here you could say attempting to sync node, right? Here, this one, if you see this line, attempting to sync node with the API server, right? This is so it is going to, as I said, it gets the instruction from the API server and perform the same. Here you could also see the address in the port. This was the one of the interview question when I was interviewed. The person asked me about how you can check the this one. Okay, kubelet the port. So this is the command in the log. I mean, there are other ways as well, but this is also one kind of option for you. You could answer for this. Okay. Yes, Mark, please go ahead.
Sorry, I wanted to tell you at some point I couldn't see your screen, but it's fine now.
Okay, okay. So here it says starting to listen address. Okay, so to check which port it is listening on, so it is, you can check in the logs. Here there is another point, is starting kubelet volume manager. Okay, and it's starting to sync pod status with the API server, right? So pod status, so everything, it is performing the task based on the API server, it's instructing, and it also sync with that, so it reports back. And here is also, you could see the sync loop, right? Starting CPU manager policies, none, we do not have any CPU policy, we do not have any manager memory policies, right? And starting kubectl, sorry, kubelet plugin manager. So I just put some of the logs, not everything, just to give you idea. Okay, so run this and dig more into what happens when this process executes. Okay, or when we when we set up a cluster, when kubelet is set up, or when this service is started on the server. So what happened? So this is really helpful when your cluster, or when you're adding a node into the cluster. I did not explain you the architecture, but it's I think it will make sense later. But still, when you add a node into the cluster, and if you want to see what happens, so you basically see a kubelet logs. Okay, though we have monitoring tools as well, but still, when we are just starting, right, setting up a cluster, when we do not have any monitoring, so this is one of the way. Fine. Next, we have the component, and which is a kube proxy. Okay, so kube proxy handles the networking for the worker nodes, and it maintains network rules to enable communication between pods as well as pods and the service. Okay, so whatever communication is happening inside the cluster, right? So of course, I did not tell you where it belongs to, but consider this within a cluster. All the network related things is handled by the kube proxy, okay, which is also one of the component. So here you could see command to view kube proxy pods running on the worker nodes, right? So you can say kubectl get pods, and we will see this namespace dash n. It means we are talking about the particular namespace, right? And kube system, then label. So labels are really important, and by the label, you, if you very good in the labels, okay, you can play very well around the Kubernetes. Okay, so Kubernetes, okay, at S you can see dash app and kube proxy. So it will give you the kube proxy pod, and its status. At the moment we had only one pod, maybe you have more. So depending on this, ideally we should have two pods are enough, but again, I just spin up the one. Okay, and I can also check the pods of, I mean, logs of this. So first I get the which pod it is, then I run a command kubectl logs. This is the name, and you can see using IP table proxy successfully retrieve nodes IP, right? And here kind of kubectl proxy configuration may be incomplete or incorrect, some error, node port address is unset. Okay, node port connection will be accepted on all local IPs. So it is basically handle the networking in between the nodes and the cluster. Okay, so yeah, that's how we see. So kube proxy, okay, which is responsible for it's a the handling the networking. Okay, then next component we have, which is container runtime. And so okay, so next container runtime, which is responsible for pulling and running container images. So container runtime, so you already guessed it. Okay, it is all related to the containers, right? And we know in day 6 we already discussed this, whatever operation we can do with the container runtime. So we can pull the image, right? We can create a containers. So all this is things performed by the CRI. So container runtime interface. Okay, it executes container defines in the pod specification and instructed by the kubelet. Okay, so that's why when we see the logs of the kubelet, you see the CRI is started, right? So kubelet, so CRI always follow whatever kubelet is saying. Kubelet is saying, okay, create 10 pods or create a 10 containers, and yeah, CRI perform that one. Okay, so that's why we need a CRI, container runtime. This stands for interface. And I just execute this command where the control plane, sorry, I should not use this term, but where my cluster is there, okay, or main node was there. We will see that. So here I run CRI CTL or CRI CTL, or however you would like to pronounce. I'm very used to with CRI CTL, or some people, I also heard people say CRI CTL, so it depends. And when you run PS, so all the related, okay, to view all the containers running on the node. Okay, so these are the container ID, image ID when created, straight name, attempt, okay, and pod ID, pod name as well. Okay, this is how we can see. Additionally, this is another command you can also execute directly over there, sudo ctr image pool, and you could give the name of the image like this. Okay, you have to provide the entire name, and then this is, you could see the image was downloaded, right? So we already saw this. in resolve done. And these are the SHA values of the layers which is downloaded, and total is 62 point this MB. Okay, so you can perform on this using this one. So this is about the container runtime interface. Okay, and when we see, so these are the all components. There is one more optional component, I think, which is not relevant over here. If you have something in cloud, so that will also comes into the play, but these are the all important component of the cluster. So you have API server first, you have database, you have scheduler which schedules the pod, right? Then you have controller. So very simple, right? We have first entry, right? So like if you go to any building, you just enter, then you go to reception, and on reception they get your all the details, right? And after that somebody will help you to go to where you want to go. And once you're there, then the person where you are going to meet, or whatever task is there, you have to meet with somebody, so that is going to manage you what you're going to do. So it's that kind of idea. Maybe this is a bad example or analogy, I don't know, but yeah, these are the components. And this side, these are the three more components. So total there are 1 2 3 4 2 3, total 7. Okay, and all these 7 components all together, they form a Kubernetes cluster. All right, and most likely, I mean, not most likely, if you see any architecture, or when you are going to work as a DevOps engineer and your architect prepare diagram, so it's very often or common practice, instead of writing the name, because architecture diagrams are really big. Okay, so that's why instead of giving the name, they use kind of this symbol, right, or icon. So this is for API, this is our etcd scheduler, or Kube-Scheduler, or Kube-Controller-Manager, kubeblade. Okay, proxy, it's kube proxy, container runtime. I did not find it, so I just want to make it CRI. Okay, and that's how the Kubernetes cluster is formed. I could also say, just for the simplicity, so I could show you next thing, I just renamed this, but icons are still the same. Okay, so this all four, okay, all four all together form a master node. Okay, so if in interview it would be asked, what are the components of the master node? Okay, so you could see, or you could say API, etcd scheduler, or if you want, you can give a full name as well, depends. Okay, and controller. And don't stop there, explain what API means. Okay, so like first you say API is the entry point, and etcd is, so just give a more information that will give a very good impression to your interviewer. Okay, next, these three side components, these are the part of the worker node. So now you know this one, kube proxy, right? Kube proxy is more, I mean, not kube proxy, kubeblade, kube proxy, or container runtime. Okay, all these three are part of the worker node. Okay, and in Kubernetes world, this part, okay, or this is called as a control plane, right? It doesn't called, yeah, it used to be called master node, or I don't remember, maybe people say master node, but control plane is the actual term for it. Okay, and why control plane? Because you have 4 components, and you can configure all these 4 components on different separate machines, even physical machines, cloud machine, wherever you want to do. Okay, and then all 4 machines all together called as a control plane instead of saying a node. Okay, so that's why, or maybe you can configure all together it on the one machine, so still that is called as a control plane. So I would say prefer to say control plane. People love to hear that, those who are really or those who are know what Kubernetes is. So if you say control plane, they will immediately understand you're talking about all this. Okay, and when you say API server, so they will know, okay, you're talking about particular component, right? Similarly, worker node, yeah, it's a worker node, it's the additional machine which actually having the workload. Fine, so this is how the Kubernetes components and Kubernetes architecture. Do you have any questions on this? Okay, someone, thank you. Okay, I take. Pradeep, you mentioned something. What is that? I don't follow. Control plane. Okay, fine. Good, good, good. So this is about the Kubernetes architecture and component. Okay. Remember, when in interview it is asked, or interview will ask you, just don't tell the name of the components. Also explain, okay, in one line, and that will be your follow-up question. Then interview will ask you, okay, what is this? And you will crack the interview easily. Okay, I'm not saying it's a trick or we are tricking the interviewer, but it's a good to give more information. So next, so we have covered Kubernetes. What is it? What architecture? It's a component, and the objects. So object is our next topic. That's why, I mean, of course I could show you, but it's better to actually show you what objects are in practice or in actions. Okay, so so these are our objectives. Okay, not objectives, objects of the Kubernetes, and we will see everything. So first we will understand. I believe you at least got an idea about nodes, right? You don't know pod deployment. We'll also see the how we can write our own YAML files. These are, it looks very big, but these are very, very, very easy. Okay, and we'll also see others as well. So all these are object. Always remember, all these are objects. Even though in your interviewer say component, don't say component. Say these are the full-fledged object which you can create in the cluster in Kubernetes world. Okay, so let's see very first thing. So yeah, instead of node, we start with the pod. I will show you how you can see nodes when we switch to the terminal. Pod is one of the important, or one of the very, very, very important thing in the Kubernetes. Okay, when you write exam, CKD, they test you most on the pods. Okay, when you see the curriculum, you could see the weightage. Okay, and as good as pod you can design, as good as you are at Kubernetes. Okay, so this is very fundamental things. We know in VM world or virtualization world, we can create a virtual machine, right? In container world, we create the list thing we can create. It's a container, or whatever the list we get, right? The smallest thing is the container, one container, right? Similarly, in Kubernetes, we create a pod, okay? And inside pod, it means pod runs a container. Okay, in Kubernetes, we do not run container directly. Okay, we always create pod and containers run inside the pod. Okay, always remember, this is the very, very confusing thing. People think, okay, pod is equivalent to container. Yes, ideally it is one. Ideally you run one container per pod, but there are some use cases where you need additional container inside the pod. Okay, I will show you how we can create multi-container pods as well, but when you really need that, otherwise it goes, or it considered as an anti-pattern. Okay, so it's like container meant to run one service within a container. Okay, it should not be like that. Okay, in your database container you're also running your application. No. So similarly in pod also, when we need extra container, so we'll come on that. But always remember, containers are different, pods are different. Okay, so consider this. That's why I showed you in this way. So container, of course this is not a virtual machine, but just understanding, consider it's a kind of sandbox environment, or it's a kind of a isolated environment, or we could say we wrap around, or containers are wrapped around the additional environment, and that we are calling as a pod. Okay, so pod is the smallest unit which we can create in Kubernetes. Okay, now onwards, whatever we will talk about, that is more higher level objects. Okay, so pod is the smallest object. Okay, of course, and you really do not maintain a container, you always maintain a pod, and in pod you define what your container should work. Okay, so always remember, your pod is the lowest level object. Lowest, it means this is the smallest unit or smallest thing which we can create in Kubernetes. Okay, and when we create pod, inside the pod container will be created, and who will create, who will manage, we will see that later. Okay, so this is clear. I believe there is no confusion on this point. Okay, we in virtualization we create virtual machine, in container world we create containers, in Kubernetes we create pod, and inside pod application will be run inside the container. Okay, and of course this is the official, I would say, yeah, official, I saw on official repository. So if you want to represent, okay, use this one. People quickly understand you're talking about pod, and this is inside pod, it's a container. So now let's see how we can create. Of course we will create in on terminal as well, but just understand. So first way we can create using a command kubectl run. I just give it a name, my first pod, and I just give a name, the image name nginx, and my pod has created. Very simple, straightforward, right? Similarly, when we talk about the containers, right, day 6, so we know there was a command to create container. Similarly, here we also have commands to create pod, and if you are going to write, and I know you will be one time decide to go with the CKD or CKD exam, go. I mean, when you write a command, of course, when I start the training, we will talk that more about, but when you are very good with the commands, you, because of the constraint, time constraint, you should be having very good grip on the command, how you can do the things with the command. Okay, so this is one of the way. And then you can run a command kubectl get pods, it gives you container creating. Okay, we will also see what this is status. There are different values of this status. I will also show you how and where you can see how you should troubleshoot. Okay, and here the basic things which I'm showing you, if you know this, you can troubleshoot pods very easily. Okay, and objects in Kubernetes very easily. So my main focus is not to show you how you can create. My main focus is to understand the fundamentals, understand where is what, okay, and understand where to look when things went wrong or goes wrong. Okay, and trust me, I started with 1.6. I know lots of things. Okay, so here everything whatever I'm showing you based on my experience. Okay, these are the things which I thought you should know. So next thing, after sometimes if you see 11 and 12 seconds, right, so after 12 seconds my pod is up and running and status has changed to running, right? So this is how we create a pod. There is another way, right? Another way, creating a pod with the YAML file. Okay, and there we don't use kubectl run, we use kubectl create -f. My second pod, I will show you the pod file as well, and pod was created, of course, and I can get the pod. And if you directly give the your object name or pod name, you can see the only output of this one, right? So this is another way. And this is the pod file, YAML file, very small, nothing special. I mean, we will see what is special in this, but just to show you. Okay, when we talk about YAML part, then we will see how we can write it, and we will discuss this in more detail. But just for now, yeah, these are the some 10-15 lines. Okay, then we have third, multi-container pod. So I also created with the same, but here the value is different. What is different? If you see, ready, right here 2-2, before it was 1-1. So this is also an interview question being asked several times. Okay, I also asked this because many people get confused on this, what is this means. Okay, so when you create this, or when we switch to the terminal, we will also see. Okay, so this side, it gives you the number of desired things. Okay, this gives you how many things are ready. Okay, so in case of when we run multi-container pod, so initially it creates first container, it will give you 1/2, so that it will give you, when second container is ready, right, it will give you 2-2. And your pod will only go into a running state, or yeah, I would say running state, when all the containers of the pods are successfully or would be ready. Okay, there are so many other ways as well you can control. So for example, how could I say that, there are liveliness props as well, where we set, right? So if you need, or your application needs to be, so for example, you are dynamically creating DNS, right? So before that, creating a DNS record, you must have kind of server, and server has some IP, and that IP should be being able, otherwise you will not be able to, I mean, you could create, and there is no point to create a DNS, right? So in that kind of situation, you can go ahead and use and control, right? So until and unless all your pods containers are ready, then after that your pods will be showing status as a running. Okay, so here is the YAML file. Okay, and here we have defined the containers. Okay, we'll talk a little bit more in details, but this is how it looks like. Okay, in specification we says container, nginx container, sidecar container, right? And these are more details. So how we can see what happened with the my pod? So simply here, if you see, I executed this command kubectl describe. So describe will give you more information about your pod, right? So I just given a name, and if you see, it gives name, namespace is the default, service account is the default, node, start time, right? Labels, annotation, status is running, IP is like this, and this is one of the snippet of these three, right? It also has the same details. And third one, my multi-container pod is also has the same details, right? When we go further, there is a section, specifically a section containers, and in containers you could see the name of the container, what is container ID, what image it is using, host port, you can see the port of this one, status you could see, right? Mounts, where it's mount, so you could see the secrets. We will talk this in CKID training, but here I'm telling you where you should look. Okay, what information when you describe. So I just put representing in a three different part, but one file when you open and scroll, you get this one. Okay, second is the same for the second, same information. Here is the important. So important, it means in containers section you can see the container, both container over here. So here's nginx container, and here is my sidecar container. And here what command I'm executing, you could see I have executed simple shell script. It's a one-liner shell script, right? So I executed over here, and yeah, restart count is also over here. So why restart count? Sometimes when you set up a monitoring, so when, or maybe alerting, so if your application or your container is getting restarted again and again and again, not container pod, right? I mean, of course container as well, why not? So you can say these values are helpful, okay, by which you can set up alert, or maybe you are interested to look into, right? So next thing, on the same page, these are the events I was talking about, right? When we go all the way down here, so you could see the events, right? So it says normal, okay, normal, and it's reason schedule pulling created, and here you could see the default scheduler, right? So it default scheduler successfully assigned default this pod to DSOC3. So this DSOC3 is name of the node, okay, where it is assigned, and it is done by the scheduler. So that's the job of the scheduler. Okay, here is the kubeblade. So actually kubeblade, here it's saying from the kubeblade pulling image, but we know it's the job of the CRI, container runtime. Okay, but in logs you will see, because kubeblade instruct and CRI follows whatever kubeblade instruct. Okay, and it also create and start the container. Okay, but inside the pod. Right. Next, if you see, this for second is the same, and yeah, this is what we are interested. So here you could see again default scheduler kubeblade. So it pulls the image, successfully pull the image. When your image get, I mean the image is not available, right? And there's one thing, when you follow along later, when you do practice, whatever errors you will get, just make a record of this. Okay, put a note in a notebook. This is going to be asked in your interview. Okay, when you schedule a pod, or when you work with the Kubernetes, even though hands-on, because if you do not have experience, you will say, yeah, in my lab environment I did this. So interview definitely going to ask you what kind of errors you get in the events most of the time. So you, whatever error you get over here, just make a note of it. When it is asked in the interview, give that answer. Okay, when I work on this thing, and explain, don't just give the error, explain like this, just as a sample. I'm just giving you the sample answer. Okay, don't just follow along, change according to your situation, and say, when I work on this thing, and I got this image pullback of error. One of the error you could see, most likely others as well. Okay, so always take a record of this. Okay, Pradeep, we are coming on that. So please unraise your hand. Okay, so this is on the part of the events. We will see that. Okay, but this also has kind of I mean, these are the pods. Okay, but pod has some a certain limitation. Okay, and what limitation? Scalability, self-healing, manual management. So when your pod get crashed, okay, it cannot be, or when you delete the pod, I will show you in action. Okay, so but just remember this thing. If you have to create, so for example, in production environment, we create one or two replicas of our application, right? So we create one or two servers instead of just one server, right? Just in case of any issue or any kind of problem happens, so other server can take over or fail over kind of, right? So scalability is the problem. If you need more ports, you have to do that manually, right? But so let's say kubectl run my first country, my first pod, my second pod, my third pod, that you have to do manually. Okay, there is no way to scale up automatically or scale back down as well. If something happened, your pod cannot be restarted automatically, right? So healing is not possible. Of course, self-management. So we have solution, which is replica set, and that is our next topic, right? So replica sets are ensures a specified number of pods. Okay, replicas are running at any given time. So when in our YAML file, or when we define the number of replicas, so this replica set, okay, which is always maintains what is the desired thing. So desire, it means, always remember in Kubernetes, desire, it means whatever you have defined. Okay, and current state, it means whatever is state of the current cluster. So for example, your desire is 300,000 pods, but your cluster cannot create that many pods because of the resources. So Kubernetes will try to create, but it will throws you error, right? Insufficient resources, right? So you have to add more resources, or you have to adjust your desire according to what you have. So that is the thing you can, but this is possible, and that can be achieved by the replica set. So that is our next topic. Let's see. So how we can create a replica or replica set. Previously it was called replication controller, yeah, but later on it's changed to replica set. It is much more better now. I like it personally. I mean, that's my personal opinion. Replication controller, it's very long, and that was also create kind of confusion, but here directly we know replica, we are talking about the replica, right? Okay, forget about that. So never mind, we talk about this. When we create like this, so one replica set is created by this command, and when we run this command, kubectl get replica, okay, you could see I directly copy paste this entire string. Okay, so you could see kubectl get replica set dot slash replica set name. So here you could see name, desired, current, ready, and age. So what exactly it happened over here? Here is the desired, because I have mentioned only one replica. That's why desire is 1, current is 1, ready is 1. Okay, this output is different than the pod. Okay, so here we have, it's a desired. So we mentioned in our YAML file, create one replica, and it is created. That's why it's saying current is 1. Okay, and which is also ready to accept the traffic. Okay, and this is the age, the time, and age is also very important, right, when you are troubleshooting. Then but come back to okay. So in replica set, right, we are talking about the scaling. So in scaling, when we run the this one create, right, and after creation, when we have this kubectl scale, right, which was not possible when you create naked pod. So naked pod, it means we are just creating a pod without any higher level object. Okay, I have opened my mouth and said this word, so let me explain. So this is the smallest unit in Kubernetes, and pods are wrapped around the replica set. So replica set is higher level object, okay, which perform additional things. So instead of, I did not read about this, or I did not tend to search on this, but as what I think, initially came with the pod, and they think, okay, let's go ahead and instead of making any changes, let's create high level object, and everything or additional functionality we will be adding to that. That's what I think. Might be I'm wrong, or maybe I'm wrong, I don't know, but that's what I think. But anyways, so here I scaled up the my replica set, and replica set, I said dash dash replicas equals to 3, right? And here you could see, instead of created, it said scaled. So, and when here the get replica set, this is still 1. So when we do this, so replica set creates additional pods. Okay, now the desired state and current state has changed. Before it was 1, and now when we scaled it to 3, so we have desired state 3 and current state is 3, and all our 3 pods are ready to accept the traffic. And when we see the pod, now here the difference. Okay, before we created a pod, so there was a name, my first pod, but here if you see my first replica set dash this some extra hashes value or some kind of additional um, string attached to it, but all these 3 has a same name except their suffix is different, right? So that's how replica set manages the pods. Okay, by appending, because when you create my second replica set, so how replica set will know which pod belongs to which pods belong to me, right? So that's why we have the initial name is same and we have this suffix value different, right? Okay, I will also show you in action, but before I want to explain the concept. When I will explain this thing on terminal, you can connect with this thing and correlate and understand. Okay, so this is about cubes, not kubectl, replica set. And again, like a pod, it also has some limitation, though it has resolved. Stupid thing I have done over here, it does not have manual management. It means we want manual management. Anyways, so it resolves scalability issue, self-healing. I will also show you what self-healing means. So self-healing, it means simply when your pod died, automatically new pod will be created, and how it will create based on the desired state as well as the current state of the cluster. And all this is stored in our etcd database. Based on that, they continuously watch on this. Okay, what is current state, what is desired state, and based on their calculation, it spin ups the extra pods. Okay, so replica set does not have rolling updates. Okay, so rolling updates is our next thing, I mean, that we will cover. And version control. So there are 2 things which is not possible with the replica set, right? Of course, sorry about this one, manual management. It, of course, it is not possible because replica set automatically perform, so we don't want it. So solution is the deployment. Okay, and rolling updates and version control, 2 are very important thing, or I would say the very powerful feature of the Kubernetes, because that provide you a facility without any downtime. you can roll out your new version of the application. So while your users live environment, so for example, let's say you're watching something on your favorite streaming platform, and they want to upgrade or add some more functionality. So while without interrupting, right, without interrupting your existing the communication or break of the application or functionality of the application, they can roll out new thing in the live environment. And that's why I really love Kubernetes. And wherever is possible, I always set up Kubernetes. Okay. And if you know somebody who is worked back in 15-20 years before, ask them how it was hard to when you have upgrade of your application. People are really afraid to touch the Linux server, to reboot it. Okay. And when containers came, it's a different story. And when Kubernetes came, it bring to the next level. Okay. So rolling update, I will show you version control. So for example, you deploy one of the application, we know version control. Yeah, for the code, similarly, we also have version control, right? When we deploy application and it didn't work properly, so we have one click rollback. So we know, okay, this version, previous version, I want to go to previous version, I will just execute the command and I'm done with that. Okay. So this is about the version control, and this is this facility is provided by the features provided by the deployment. So what happened in the deployment? So of course we can create with the command kubectl create deployment, my first deployment, image name, and it created deployment for it means Kubernetes, right? I can simply say kubectl get deployment. Okay, it says one because I mentioned one desired, one current. Oh, good. But what is the different over here? When I created a deployment will automatically create a replica set for you. Okay, it does not, I mean, you really don't care about replica set when you create a deployment. So deployment is again a more higher level object, okay, in Kubernetes. So when you create deployment, it will automatically create a replica set for you, right? And that's how we can check. Either you can type replica set entire thing, or you can type rs, whatever is your preference. Okay, I just showed you this one, so rs is better, I believe. It saves time. And let me save your time to go to the next thing. And replica sets create a pod for us. So we saw already in previously before the deployment, we talk about replica set, right? So instead of creating a pod, we created replica set, and replica set manages the pod. And here additional features or functionality provided by the deployment, rolling update, and the versioning. So we chose to create a deployment, and when we create a deployment, okay, it's an object. Okay, so deployment itself is a different thing. In Kubernetes, deployment is the object. Okay, I will show you the YAML files that will give you more idea about. Okay, so here deployment, and deployment created this replica set, and this replica set, right, it's responsible to create a pod. So you could see now in replica set the replica set name and some hash values for the suffix for the pod. So similarly here deployment created and deployment created replica set. So how deployment knows which replica set it belongs? So it just adds some my name, so my first deployment dash this hash values suffix. Similarly replica set is also maintaining by this. Okay, and that's how the deployment are created. And honestly, you really don't directly interact with the pod in the production. You only create a pod when you are writing CKD exam. Okay, kidding. I mean, of course, that is one of the thing. But in actually, when you have to create or test or doing debugging before actually setting up, right? In that case, you create a pod. But in as a DevOps engineer in real world, we really don't care about how pods are being created, how replica sets are being created. We only create a deployment. Okay, you may be thinking why you waste our time and explain pod and replica set. So the thing is, I said very initially, as much expert or as much as grip you have, or as much as beautiful pod you can create, as much as control you have on your higher level object. Okay, so are we done? So here, create deployment, right? Get deployment, get replica set, and get pods. So this is how it happened. So we are not here done with the all these three things. So consider this as a deployment as the manager. Okay, so just like manager in a workplace, the deployment gives high level instruction, okay, and sets objectives, so like desired number of replicas, container images, and monitor the progress. Okay, and it also ensures the system operates smoothly. It handles updates or rollback and intervenes when the things go wrong. Okay, so the manager oversees everything but doesn't directly execute the task. So remember, deployment doesn't directly execute a task. Okay, it delegates to the replica set. Okay, so deployment manages replica set. So consider replica set as the team lead. Okay, so the replica set is the team lead and take orders from the manager. So here manager, it means deployment and translating them into action. Okay, and it handles the uh, hands-on responsibilities of creating and maintaining pods. Okay, and ensure the number of replicas matches the deployment's instruction, whatever replicas mentioned in the deployment. Okay, so desired replicas, it means whatever desired things are mentioned, which is managed by the replica set. If pod fails, the team lead response, or sorry, the team lead, here the team lead is replica set, that ensures the replacement is created promptly. So now you know the limitations which I showed you in order, right? Scaling and self-healing. So that belongs, or that belong to replica set. Okay, so if we are scaling up or scaling back in, it means it will be performed by the replica set. Okay, version control and rolling update, it is handled by the deployment, higher level work. Okay, which is really required manager intervention. And last thing, so deployment manages replica set manages pod. So pod is as a team member. So pods are the hardworking team members. They're actually carrying out the workload. So the workload here, it means running your application or service, and they report to the replica set, right? And here the replica set is the team lead, which ensures they are up and running as expected. Okay, if a team member, so team member means pod, is absent or fails, the team lead takes care of bringing in a new member. Okay, so in short, deployment manages replica set manages pod, and pod runs the container. Okay, very simple hierarchy. I try to explain you um, as low as I could. If it is still high, or if you still have doubt, please ask me, because these three things are really important for our rest of the object. Any questions so far, guys?
Well understood by me, sir. Thank you.
Okay, thank you. Okay, guys, please, if you have, ask me. Let's go ahead. Okay, so always remember, deployment is highest level object in Kubernetes. Okay, which manages or which instruct replica set. Of course, manages is also correct word, and replica set, which is actually create or manages the pod, and pod is our actual worker, or they carry the workload, right, as a team member, and that runs the container, your actual application. So here quickly summary. So replica set. Then I finally come to a conclusion to remove that manual management part. Then I remove that. Now it looks better. So yes, replica set, scalability, self-healing. Okay, so when you scale your application, again guys, why I'm telling you, maybe you're thinking it's a theoretical part, that this covers most of your basic fundamentals and your interview questions. Okay, so if it is asked, when you scale up and down, who handles, so you know who handles the scaling, who recreated a pod. Okay, so self-healing, it means when something happened with your pod, it means in your cluster applications pod, then pod will be automatically recreated. I will show you. shortly, and we are coming on that. Okay, so these two things on this. And here when we create deployment, so don't think deployment is actually doing this. I mean, of course we will be doing with that, but this is the responsibility of here. Okay, so here we done. So yeah, before we go ahead and actually get our hands dirty, one more important thing, and which is YAML or Kubernetes, right? Let's see what YAML in Kubernetes. So YAML files are used to define and configure various objects like pods, deployment, service, config map, all the objects which I showed you before. So there are two ways. You maybe notice we created the pod using a command kubectl run, and we also created a pod using a YAML file. So there are two ways. One is imperative way, another way is the declarative way. Okay, so in one you create pod by the command, one you create a declarative way. So declarative way is actually you are doing in the writing a YAML files. Okay, and these are preferable way in your production workload, okay, or production environment, because you can version them, you can check those file in with your application code and put them in a repository, right, where you can track what happened. I mean, track it doesn't mean you micromanage the who has done what in your teammate. So something happened in the application code, we know, we talk about in our git, I think 1 2 3, yeah, day 3, right, git and github. Why do we need to maintain the versioning? Okay, so we can, I mean, let's not go into that. Want to refresh, go ahead and do that. So how we can do it here? So there are, when you write any of the YAML file, okay, very first thing you will write in there is, it's very simple, very simple, very much simple, I would say. Okay, if you think, after when I show you, if you think it is not broken down, let me know, I will do it more. Okay, so very first thing in a file, so it's like Docker file. When we write from instruction one first to know where is, I mean, what base image we want to use. Similarly, when you write a file, okay, sorry, I did not change it, so don't think I'm going to show you here the deployment. So it is not related to the deployment, just ignore it for some couple of slides. Okay, so this is not part of this one. So when you're writing YAML, so first you have to write API version, and you have to write in the same way, API capital V version. And what you do over here, or what it does, you have it explain, define the Kubernetes API version. Okay, so it is depend on what things you are gonna, or what object you are going to create. Okay, depending on that you have to change this one. So you have version v1, apps/v1, batch v1, policy. So as for working as a DevOps, you really don't bother about. Okay, you have simply the command, okay, kubectl API versions, that will give you the version, and kubectl API resources. Okay, execute this command. We will also execute and see what kubectl API version, by which you could see which uh, resources, yeah, or objects, yeah, resources has which API version. Okay, so this is the first thing you mention in your API. I mean, not in API, in YAML file. Okay, which defines the Kubernetes API version. Second thing you have to mention, this is kind. Kind is, it's a straightforward, right? Specify the object, right? Object type. Whether you want to create deployment, whether you want to create pod, whether you want to create service, config map, whatever, stateful set, daemon set, job, cron jobs, whatever, right? So you have to put in kind. Next thing you have to mention metadata. So metadata is, it looks like this one, right, in our pod. So it basically has two things. You always have to mention what resource or the kind. So for example, you are creating a deployment or pod, you want to give a name to what is this pod. So I just given my second pod, so maybe it's a front-end application, so you could say the front-end application pod or backend application pod. That is more relevant and can be understandable by everybody in the team or in the company. Okay, so that's what we provide in metadata. We also provide levels over here. So whether environment is production, development, DSOC 3, there is no such environment. Okay, so you provide testing, development, or some meaningful. For me, it's a meaningful, of course, but In real life, it's a different. Okay, I will show you. It can be anything. So this is your third thing. First thing is API version, where you have to define the version. Okay, second thing is kind, where you know, and most of the things you already know what you are going to define. And metadata, you know the name, right? And then we have a spec. So spec section, where you specify the object desired state, right? So in this case, we have spec replica 3, or in spec section of pod. So this is this it's a different, it belongs to replica set or deployment, where you define the replicas. Here you set containers. Okay, so here I just given a name, my container. Like this you specify in your spec section, and you are done. You only need 4 things to write your YAML file. That's it. You don't need anything else. I mean, anything else, it means of course you need it, but these are the more 4 I would say the objects in your, not objects, 4 components, right? Or 4 things in your YAML which are mandatory, you will encounter everywhere. Okay, API version, kind, then metadata, and then the spec. Yeah, Pradeep, please go ahead. You have question? Is kind, is key, it is. You can speak up. I don't follow the text question.
Am I audible, sir?
Yes, please.
Okay, so I'm asking, like, this kind we are writing, going to write the kind. So is it Kubernetes and Docker, or it's a different tool?
Kubernetes in Docker? No, it's a YAML file, and in Docker we simply file a Docker. I mean, we write a Docker file where we define instruction, right, for the Docker file that is understood by the Docker. Here, the file, the things which we are defining over here, these are understandable, or this will be understood by the Kubernetes only.
Okay, clear.
Okay, good. So yeah, so these are the 4 things we need. Yes, there are more things, but these are the list. Okay, without this you cannot create your YAML file, and if you know this 4, rest will be okay. Okay, so again we check, and of course one more thing, this YAML, it really does not mean you need to learn YAML. I'm not discouraging you. Okay, so don't take it in that way. If you know, it will be better. Okay, as I will always say, more you know, more is better. But you're starting, so it seems like I also started when I realized nobody was there to guide me and says, okay, oh my god, I need to first learn YAML. So I did that, and then again come to the Kubernetes. But guys, honestly, that really didn't help me, because in Kubernetes YAML files are different than the YAML which you learn. Of course the concept is same, but honestly, when you keep on working with this thing, this will be a cup of tea for you. Okay, so if you wish, go ahead and learn, but I really don't think, but yeah, your decision. So if you see here, this is our pod file, pod YAML file. We have API version v1 here in kind. I mentioned second thing is a kind. Okay, pod, and metadata, here I given a name, a label, environment, and here as I said, labels. Okay, so many people have confusion when you see in example it says, okay, name nginx, label nginx, nginx image, nginx container name, and which is really confusing what is happening what. And we started to follow the same thing. When you copy that YAML and work in your environment, so instead of putting your head why it's this name, right? So you, it means not, I'm not pointing anything to you, but it's better you know what is happening what. Okay, so everything is different, so don't just blindly follow the example, go why you are writing this thing. So for example, in this case, when you write it, can it be anything? Yes, so you have to put it in inverted, because it's a string, otherwise it will show you it will throw you error. Okay, unmarshal or something, YAML error. Okay, So that's why I put this in this way. If you have one word, it's okay. Then spec is the fourth part, and is spec where we define object desired state. So this is our object in our desired state. Okay, of course in object is the pod is the one pod, right? If we have multi-container, so our desired state is to multi-container pod, but here the desired state is single container pod. So my second pod container, so let me tell you once again, or walk you through once again. Find his metadata name, whatever name you want to give. So whatever, if for example you find on the internet, here it says nginx, it means you are giving a name to your pod which is going to be created. Okay, then labels. So label will be helpful when to filter out, right? When you have thousands of nginx container, so you can simply say, and okay, environment, so let's say -l, it's a label, and label environment equals to dsoc3. So that will list you all that particular pod. Okay, so that's why we use the labels. And spec, in spec we says containers. Remember, this is container, right? Give me a second, guys. Okay, so is my, yeah, so this is the labels. Okay, and spec. So here in containers, right? So you need to know two things. First thing, there is a thing, it's a map. There is one another thing is the list or array, right? So here, or dictionary, it is called in YAML like that. Okay, so when you see something metadata colon, and I have put two names, right? Inside this, again two things is there, right? In spec I have one this thing, and it is container, and it has dash, right? And again here port, then we have dash. So whenever you have something like this which is starting with the dash, okay, which is your list or array. Okay, so when you I will share this YAML file with you later on. So reverse the order of the name. So nginx and the sidecar container, I think it was a busybox. Okay, so when you try to create, just change the sequence of this, you will get to know why, what happens. Okay, and it's containers, right? Here we have ports, it means here we can define multiple things. So multiple ports can be defined over here. So maybe your container is listening on more than one port, right? So where here we define a port, right? So number of ports. And containers similarly, because it's a container, so we could have many containers over here, right? So yeah, that's about this one. And when we see the replica set, so replica set is higher level, but again here we also have the same API version, kind, metadata, and spec. And in spec, here we have containers, but here we have replica set, sorry, replicas equals to 1. So yes, of course, it's a desired state of our object. So we want in spec we define that. So we have replica equals to 1. Selector, we will come on that. This is one of the very important topic. And app equals to my second pod, right? And you could see here the name is my first replica set, but here I have given a name app equals to my second pod. But here additional one more thing we saw, the template, right? So what this template, what does it do here? So all these things above here is specifically spec, right? In spec section we have replicas and selector. And if you see in template, so let's go ahead and see in the template. So template contains the metadata, labels. Let me make a zoom of it. Yeah, so template, metadata, and in metadata we have labels. Labels is like this, like this, like this, and in specification we have containers and the name of the container. So basically what happened here, it's a no big deal. What is important in replica set up to over here, this template is very similar to what we have over here. When you see this metadata and this metadata, I mean, of course both are same, no different. But if you see labels, so here we have labels app, additional, and env dsoc3, and can it be anything? Yes, if we see the specification, so template is also has its own specification, containers, and my second pod container, image nginx, port, and container. Everything is same from, so everything whatever is over here metadata. So just remove this API version v1 and kind pod and put as is everything under the template. Okay. Here in replica set where people get confused, this mesh labels, okay, and this labels, and some places where you also have, because in metadata I said you put either, I mean, name and the labels, right? So people again get confused, what this labels means over here, what labels mean over here, what labels means over here. We will see that and understand each and every level labels are have some specific meaning. Okay, but replica set file is very simple. These four things: API version, kind, metadata, spec. And in spec we have to define the replicas because scaling is handled by the replica set, right? And by this actually mesh level, let's just hold on this for a moment. Similarly, I have a file, okay, and that file is for deployment. And when you see all this thing, API version, here we have API version, here we have API version, here we have kind pod, here we have kind replica set, here we have kind deployment. Here metadata, I just given a name, my second deployment, my first replica set, my second pod, right? Why shouldn't I give my first pod and my second deployment? I will tell you later. And of course, here I omitted the labels. If you want, you could feel free to provide, follow it, do it. We will see that. Okay. And again spec is there, and so these are the high level 4 things in all the YAML files. Then we have replicas. So now we know from metadata to spec we have just put it inside the template. Okay, this template, it means here we are mentioning and we are giving the information to replica set. Okay, when you create a pod, use this template and create pod like this. So that's why we really didn't do anything whatever we defined over there, because first we tested a pod and based on the pod we created a replica set. And that's why I said as beautiful as pod you can create, as beautiful high level object or more controllable high level object you can create. So whatever is important thing you perform over here. Here no fun at all. Okay, you just put this part over here. And then if we see, deployment also has the same. Let me compare this two section for you. I put it very far. Yeah, so template and template, metadata, labels, my second pod, the SOC3, can it be anything? Yes. And specification is also the same. So if you see, both files are same, right? So what is the difference? Where is a rolling update? Where is versioning? So that we will see in action. Okay, so how this happen? We will deploy pod, we will deploy replica set, we will deploy a deployment as well. Okay, and yes, so that's what we are going to cover in action. So far, oh, sorry, not this one. Yeah, come on, this. Yeah, okay. So guys, I think I have given you the enough background foundational on this part, right? And we are already over time. So in next week I will be showing you everything in the action, how we can create a pod. Okay, and because otherwise it will go too much long. I don't want you to break the hands-on session. Okay, theory part we can, or conceptual part we can break, right? We can split up, but when we start creating a pod, it is going to link with the replica set, it is going to link with the deployments, and that will really link with each other. So I don't want to break a flow. So I would like to stop over here, and I open, I mean, in next session, of course, next week, we are going to see all these things. So we are going to see all these things, okay, in action. We will deploy our, we will see how we can deploy node, how we can deploy pod, how we can deploy replica set. Deploy, it means we can create. I would say better to create, not deploy, because it creates confusion. We'll also go ahead and create deployment, stateful set, daemon sets, config map, and all these things. Okay, So now I open a platform for your questions. Do you have any questions? Whatever we have discussed, I know it took around 2 hours to almost 2 hours, I think. Yeah. So just to explain the concept. But I hope that was not painful and you at least understand the basic fundamentals. Okay. Do you have any questions? Oh, thank you so much. Okay. Anybody else? No. Yeah, yeah. Yeah, Pradeep, I would say you would be able to connect the dots, but you understand now. But okay. Okay, so then uh, I would like to wrap up over here. As usual, our email address in case of any questions. And thank you very much. Today's session is amazing because of you. Yes, thank you very much. Definitely, I will, whatever I have explained in theory, I will explain you more in practical. Okay, because this creating animations, I mean animation, that means the putting concept into this kind of things will take time, and really I spend a time over here because here these are the basic building blocks. Okay, now we know these are the things, and now we have very strong foundation. In next, when we start hands-on, we will directly jump into the hands-on. I will show you really amazing thing. I will show you what you will do in actual production system. Okay, we'll write everything. I will also give you the tricks as well. That's why I said you really don't need to go and learn. I mean, of course, I encourage you. I'm not discouraging you. Go ahead and learn if you. But first, go ahead and learn this. But my personal perspective, my personal belief, you start working on the things, you will definitely used to with this. Where you have to put ports, where you have to put replica set, where you have to put rolling updates, strategies, user, and everything. Okay, volumes, all this. So yeah, we'll do that in next week, and be prepared. Next week session is gonna be long, so I will also make sure have some availability, and yeah, accordingly we will do that. So I wish you a happy weekend, and guys, see you next week. Thank you very much, Pradeep, Anish, Samar, and Raj. Bye, guys.